Hi students, welcome to Future Dr. Neet Academy for the problem solving session in Neet Physics. Topic chosen today is from chapter 8, Mechanical Properties of Solids. Already we have spread 7 questions in the previous session. Now we are going to solve the solution for these 7 questions. Let's move to question number 1. A wire of length L, area of cross section A, is hanging from a fixed support. The length of the wire changes to L1 when mass M is suspended from its free end. The expression for Young's modulus is dash. What is the formula? Young's modulus Y equal to stress by strain. Normal stress by longitudinal strain. And stress equal to force by area, we know the formula, and strain is nothing but change in dimension to the original dimension. Here change in length and original length. So simplify this as F divided by A into delta L into this L comes up. FL by A into delta L. Okay, and delta L equal to L1 minus L. Delta L equal to L1 minus L. L is the original length, L1 is the change in length. That is the final length. So L1 minus L is the only change in length. Substitute this here. Then Y equal to F into L divided by A into delta L is L1 minus L. L1 minus L. That is which option? And F equal to M into A, that is equal to M into G. And substitute this here, Y equal to M G L divided by A into L1 minus L. That is option C. Option C is the correct answer. Let's move to question number 2. Two wires are made of the same material and have the same volume. The first wire has cross-sectional area A and the second wire has cross-sectional area 3A. If the length of the first wire is increased by delta L on applying a force F, how much force is needed to stretch the second wire by the same amount? Formula, same formula, that is Young's modulus Y equal to stress by strain, that is F by A into delta L by L. And here same volume, volume is constant. Then volume is constant means V equal to what is the formula? Area into length. Okay, V equal to area into length. And from this length L equal to volume by area. Okay, volume by area. Volume divided by area. Okay, L equal to V by A. That if you substitute, then FL by A into delta L becomes FV by A1 delta L. Here you want to find what? Force is needed to stretch the second wire. So Y equal to F1 V by this, then F1 equal to what's the formula? Y into A1 square delta L divided by V. Similarly, F2 equal to, F2 equal to, what is the formula? Y, that is a same material. So Y1 equal to Y2 equal to Y. So we kept Y into A2 square. Y into A2 square delta L divided by V. And A2 equal to 3A. Okay, before that we will simplify. F2 by F1. F2 by F1 equal to Y A2 square delta L divided by V into F1 is YA1 square into delta L into F1 is YA1 square into delta L into V. Now V getting cancelled, Y same material, Y getting cancelled, delta L getting cancelled. Now A2 square by A1 square equal to A2 square A2 square by A1 square. A2 equal to 3A, A1 equal to A. Then 3A whole square 9A divided by A. A getting cancelled equal to 9. F2 by F1 equal to 9. Then F2 equal to 9F1, that is equal to 9F. That is option C. Option C is the correct answer. Let's move to question number 3. The bulk modulus of a spherical object is B. K or B will be used. If it is subjected to uniform pressure P, the fractional decrease in radius is dash. Formula: bulk modulus P equal to F by A into delta V by V. Your fractional decrease in radius they asked. So from this delta V by V, first you simplify. Delta V by V equal to, what is the formula? F by A. F by A equal to pressure. Pressure P equal to F divided by A. So that is pressure P divided by B. P by B. This is a fractional decrease in volume. We want to find fractional decrease in radius of a spherical object. What is the volume of a sphere? What is the volume of sphere? Is it 4 pi r square? No, 4 pi r square is the surface area of a sphere. Volume of a sphere is 4 by 3 pi r cube. That is volume V equal to 4 by 3 pi r cube. Then delta V by V. Delta V by V equal to, what's the formula? 3 into delta R by R. 3 into del R by R. Then delta V by V equal 3 into delta R by R, and we want to find delta R by R only. Is it so? So from this, delta R by R equal to, because fractional decreasing radius only we want to find. So delta R by R equal to 1 by 3 into delta V by V. 1 by 3 into delta V by V. But delta V by V equal to P by B. Substitute. Equal to 1 by 3 into P by B. One by 3 into P by B. That is equal to P by 3B. Option D. Option D is the correct answer. Let's move to question number 4. Copper of fixed volume V is drawn into wire of length L. When this wire is subjected to a constant force F, the extension produced in the wire is delta L. Which of the following graph is a straight line? So here with something constant, was the force is constant, and the same material Young's modulus constant, and volume is constant, fixed volume. So volume also constant. We know the formula, volume V equal to A into volume V equal to A into L. A into L. Okay. Then from that, A equal to what's the formula? V by L. V by L. Substitute Y equal to FL by A delta L. Substitute for A equal to V by L. Then our required formula is Y equal to FL square by V into delta L. This is our derived formula. And here question is, we want to find the relation between delta L and L. Delta L and L. So all the things constant. Y is constant, F is constant, V is constant. Then delta L, if you bring this side, delta L is proportional to L square. Which option? Option B. Option B is the correct answer. Let's move to question number 5. The following 4 wires are made of same material. Which of these will have the largest extension when the same tension is applied? Same tension means same force. When same force is applied, same material, so Young's modulus also Y same, then which of the following is having largest extension? Extension means delta L. So our same formula only, Y equal to F L by A into delta L. F is the force applied, A is the area of cross section, delta L is only extension produced, and L is the original length. Now delta L, if you simplify this, delta L is proportional to L by A. Okay, this is the formula. This is our derived formula. Delta L is proportional to L by A, and largest extension, that is delta L is proportional to L by A, and in this combination maximum value is length is 50 centimeter and diameter 0.5 millimeter. This extension only having, this option only having maximum value. Okay, so delta L is proportional to L by A is maximum for option A. Let's move to question number 6. The stress strain curves are drawn for 2 different materials X and Y. It is observed that the ultimate strength point, that is here is ultimate strength point D, point D. Ultimate strength point and the fracture point is E, are close to each other for material X and but are far apart for material Y. We can say that materials X and Y are likely to be dash. That is, if the distance between D and E is small, then that material is brittle in nature. What is brittle? By breaking or by applying force, it will be broken into pieces, like just like glasses. Glasses are brittle in nature. Okay. So if D and E value is very small, then that is brittle. Distance between D and E is small, then it is brittle in nature. Brittle. And if D and E is large, then that is good for elastic nature. That is having high elasticity or high ductility or high malleability. Okay, so option B. Option B is the correct answer. Let's move to last question. When a block of mass capital M is suspended by a long wire of length L, the length of the wire becomes L plus L. Capital L is the original length and small l is the increase in length. The elastic potential energy stored in the extended wire is dash. Formula is basic formula. Elastic potential energy U equal to half into stress into strain into volume. Okay, what is the formula for stress? Stress is nothing but force by area. So U equal to half into stress is force by area into strain. What is the formula for strain? Change in length to the original length. Delta L by L into volume. Volume, how can you write? Volume is nothing but A into L. That is, volume is a 3-dimension, area 2-dimension, length 1-dimension. A into L becomes volume V. Okay, previous problem itself we discussed V equal to A into L. Then this AL getting cancelled. This A and this L getting cancelled. What's the remaining thing? Equal to half into F into delta L. Delta L only is given as small l. Delta L equal to L. So U equal to half into F into L. This is our derived from formula. And here mass M is given. So what is the relation between F and M? F equal to M into G. Yes, they give capital M. So we will use capital M as it is. F equal to M into G. Substitute this here. U equal to half into F into L. There 1 by 2 into M into G into L. Of MGL. That is which option? Option B. Option B is the correct answer. Okay. Thank you, students. In next session, we will see through next